everybody, and welcome to our Chapter 7 lecture for our C# programming course. In this lecture, I've put together a few slides here where we're basically going to go over some of the concepts that are learned in Chapter 7 of our course text. And then after we go through all of the slides that I have here, I do have a short little live coding type of example that we'll go through as well to see some of these concepts actually applied inside of a program. So as a chapter 7 overview, what is this chapter about? So inside of this chapter, we read about why programs crash, what exceptions are, how to catch and handle runtime errors, displaying error messages, and validating user input. And this chapter is very much about writing safer programs that handle unexpected situations without crashing. So, why do errors matter? Well, ultimately, users will enter invalid input. Files may not exist that you're trying to access, and data conversions can fail. And these three bullets here, they're all examples of errors that can occur during program runtime, hence why we call them runtime errors. And we want our programs to fail gracefully and not crash. And it is important to note that errors often happen due to things that are outside of the programmer's control, which is why it is very important to take them seriously and write our code to try and prevent errors from happening. So let's say, oops, sorry, I accidentally hit my mouse DPI. Let's say that we had the following code. We had a variable named age. It is an int, and we are trying to assign it the value of our user input here, but we're parsing it to an int. So ask yourself the following questions. What would happen if the user typed 20 and it is the numbers 20? So the code would run fine, right? And that's because parse assumes that it's going to get valid numeric input, and 20 is valid numeric input from the user, so it would work fine. 20 is an int, so it would be fine to be stored inside of the age variable. But what would happen if the user typed 20 and used letters to spell out the word 20? Well, then we would get an error. And that's because the parse method that we're using here assumes valid numeric input. So if that assumption is wrong, like in the case of typing 20 with letters instead of numbers, then the program cannot continue safely. So let's take a look at what an exception is. So an exception is a runtime error, and this is different than a syntax error, right, which is caught at compile time. So runtime errors only occur during runtime in the form of exceptions, and syntax errors are caught at compile time. And usually when you're in the editor, right, whenever you see the red squiggles, that is the editor warning you that there is a syntax error. Sorry, I didn't mean to scroll. So this means it occurs when the program is running, right? And an exception will stop normal program execution, and it needs to be handled or the program will crash. So some common examples that you may see are format exception, divide by zero exception, which is obviously when you divide by zero or try to divide by zero, and null reference exception. These are all very common exceptions that you may run into. There are obviously more than these, but I just wanted to give you an example of a few that you may have seen already in trying to write different code. So how do exceptions work? Well, the CLR, which is the execution engine of .NET, detects an error first. Then an exception object is created. The program will then search for a handler, and if none are found, the program terminates. So basically, to summarize these four steps of how an exception works, basically when something goes wrong, the CLR looks for code that knows how to respond. And then obviously, if there is no code that knows how to respond in the form of a handler, then the program will terminate. And obviously, if we are writing programs, we don't want our programs to be terminating early and not doing what they're supposed to do, which is why handling exceptions and validating input is so important. So let's look at an example of an unhandled exception. Okay, so we have a variable named number, it is an int, and we are trying to assign it the value of ABC, the letters ABC, and we're trying to do a parse on ABC. And then obviously we're trying to write the number variable to the console. So in this above program, the program is obviously going to crash, right? Because here you can see that we are trying to take letters which are not valid int input, and we're trying to parse them into an int. So it's obviously going to fail. And if this is all the code in our program, there's obviously going to be no recovery, and the user is going to have a poor user experience. And the reason that this is going to fail is because there's no try catch block. So the program has no instructions for how to recover. So as a to talk about structured exception handling, we can use structured exception handling to safely respond to runtime errors. And this comes in the form of the try catch blocks. So the try block of code is for code that may fail. So it's for the risky code. And the catch block of code is the code that will handle the error, right? So this is our recovery code. And this try catch block of code here, this is what helps prevent program crashes. So here you can see the syntax I've included. Sorry, it's a bit smaller, but we're going to look at it in a second on the next slide as well with some actual code in there. But you use the keyword try with open and close curly braces, and you put your risky code inside of the try block, and then you use the keyword catch, and inside of the catch block, you'll put your recovery code. So let's look at an example of catching an exception. So we have our exact same line of code here. Our int age is equal to int.parse textAge.text. So we put this in our try block because this line of code could fail if we were to enter 20 spelled out in letters, right? This would fail and throw an exception. And in our catch block is the recovery code. So if an exception is thrown in the try block, or more importantly, the moment that parse runs and fails on this text, then the catch block will immediately be run, right? So it'll say messagebox.show, and it'll let the user know that they have entered invalid input. And that's why the code has failed here. So using these two blocks of code here, this helps prevent a crash. It allows for user feedback, right? Because we can let the user know that they put in invalid input, and then the program will continue running. So this is a very handy tool and should be used in programs, especially in programs where you are getting a lot of user input. So catching the exception object. So the exception object contains information about what went wrong. And there is a message property on the exception object that gives a readable description of the error. So for example, I have a catch block of code here, and you can see in parentheses, we have an exception X. And this variable here represents the exception that was thrown, and it is a very general catch for any exception. But you can put in a specific exception here if you were looking to catch a specific exception. We'll talk more on that in a little bit here. But what we're doing is we are catching an exception X, and then in a message box that we are popping up on the user screen, we are saying X, which is the name of our exception, dot message. And this is the message property we talked about that will give a description of the error that occurred. And then, as I've already said, you can catch specific exceptions instead of a general catch like exception X. I do briefly want to discuss exception properties and methods. So message is one property on exceptions, but another property is stack trace. And what stack trace does is it lists the methods that were called before the exception occurred. So this can be very handy, especially for devs, because you can actually see the call stack, and you can see where the program. You can basically trace back all the methods that were called and be able to better debug your program, so you can see where it is going wrong with the exception that is getting thrown. Um, and we do also have a method called the getType method, and this is used to get the type of the current exception. Okay, so we can know specifically what kind of exception was thrown. We can also use multiple catch blocks. Okay, so you can use multiple catch blocks to try and catch specific types of exceptions. This is very useful if you are just trying to, if you're trying to catch specific exceptions, and you know that there is, 2 or 3 exceptions that could occur. Then you could use multiple catch blocks. And to use multiple catch blocks, you're going to use the same syntax as one catch block, but you can just add as many catch blocks as you need underneath the first catch block. As a note, there is a finally block that you can use, and this can be put after all of the catch blocks. And this code will run whether or not an exception occurs, and is usually recommended to be used for cleanup. Okay. And as a note, I forgot to include it in the slides here. But as a note, when you're working with catch blocks, you'll want to do specific catches first. Okay, so you'll catch specific exceptions first, and then you can do general exception catches after you've done all these specific exception catches. Okay, and that is just a good rule to follow. And I believe it's required actually by the C# engine. So throwing in an exception. So you can manually throw your own exceptions, and these can be a new exception or an existing one. And to throw a new exception, you'll use the new keyword, obviously. So when should you throw an exception? Well, you should throw an exception when a method can't complete its task. You could throw one when you want to generate an exception to test an exception handler. And you could also throw one when you want to catch the exception, perform some processing, and then throw the exception again. So let's move on to the other side of the coin a little bit here, but they kind of go hand in hand. Data validation. So there's many ways to validate data, and the great way to validate data is by utilizing if statements. Okay. So by using an if statement, you can check if data is in range, you can check if the data is valid, and you can check that an entry has been made. So also to note with data validation, you'll want to display an error message if data is ever invalid. The user, when they enter data, they're not trying to enter invalid data usually. So you'll want to display an error message so they can know exactly what they did wrong and what to do to fix that mistake. And to make the data validation process easier, you can also code custom methods. And these methods can check a required field, a valid numeric format, and a valid numeric range. These are obviously not everything you can do, but those are some of the main ones for validation. And breaking this validation code into methods can help make your code a lot cleaner, and it can be a lot easier to reuse these methods for different validation checks throughout your program. And as a note, if you had multiple text boxes to validate, you could also validate multiple entries at once. And the book chapter actually goes into a great example of how you could do that. So instead of kind of beating a dead bush and going through that specifically here with you as well, I would recommend looking through the chapter and seeing how the author did that, because I think that's a great example. So just to compare really quick, validation versus exceptions, and to give, a clear idea of the difference between these two. Validation prevents bad input before it's used, and exceptions handle unexpected runtime errors. And good programs are going to use both of them together, right? So validate first and then catch exceptions as a safety net. This is a good rule to follow here. And then I also want to introduce, I don't know if we've discussed try parse before, but if not, I want to introduce you to parse versus try parse. So parse is going to throw an exception on failure, right? We've seen parse before, we've used parse. On failure, it just throws an exception. Try parse is going to avoid exceptions and return a true or false value, okay? So here's an example of using try parse. We have int.tryparse, and then we are trying to parse the txt age.text property, and then we are using the out keyword to send out the age. And do note that try parse will return true or false, okay? And before we look at I'll look at this end of lecture slide with you really quick, and then we're going to take a look at a coding example of using some of these validation and exception concepts. So just end of lecture, some things to keep in mind and key points really from the entirety of this chapter. Exceptions occur at runtime. Try catch prevents crashes. Catch specific exceptions when possible. Validation prevents errors before they happen. So always, always, always validate user input. And professional software must handle errors safely, which is extremely important to remember, especially as you are learning this language and learning programming in general, in hopes of one day working on professional software. These concepts are extremely important. So I do have a project here that I have started, just gotten the groundwork for here, and I'll go over what I've done already. And then we will actually do some work on it as well. So I have a label here, enter age. I have a text box, which I believe I have named txt age. Yep, I've named it txt age, so the user will input their age. And then we have our check age button, which is going to kind of just, it's not going to calculate their age because they're entering their age, but it's going to, return a sentence. And there is actually a label here that you can't see because it is empty, but that label is what displays the output. Okay. So, and then I've already set up just some basic stuff here for our check age click method here. So when we press our check age button, we create a variable named age. It is an int, and we assign it the value of int.parse, and we are parsing the txt age.text and assigning that to the age variable. Then our label result, this is the label I was talking about that has the output. We're going to set the text equal to you are age years old, right? And age is the variable that we're creating here. So this is just the starter code that I've created here, but you can probably see where some issues are going to arise from this code. So I'm going to go ahead and run the program. And to start, I'll just enter 25 for my age, and it displays you are 25 years old. Perfect. But what happens if I type in 20? And I hit check age, and you can see that we get an error, and it tells us that an unhandled exception has occurred in our program. And it also lets us know that the input string 20 was not in the correct format. So we can go ahead and quit. And you can see that our program has crashed here. So why don't we first try using the try catch block to try and handle this exception, okay? So what I'm going to do is I'm going to say try, and then I'm going to open a curly brace, and then underneath these two lines of code, I will close a curly brace. And then obviously we need a catch as well. So we're going to go ahead and do that. So now we have a try catch set up. So we're going to try the parse and try setting, basically try the parse and setting the text here. When the parse fails, if the parse fails, it'll go to the catch block. And here we'll say message box.show. And we are going to let the user know that they need to enter a valid number. So we'll say, please enter a valid number. Okay. semicolon at the end there. And we can save that. And then now let's run our program and let's see what happens here. Okay. So give that a second to load here. There we go. So let's type in 20 this time in a letter format. So you can see that a message box has appeared and it says, please enter a valid number. So what happens here is parse is throwing an exception because this is not valid input. The execution is jumping down to the catch block of code here. And instead of crashing, the program shows this message box letting us know to enter a valid number. So we can press OK. And then now you can see we could change it. We could say, oh, we're supposed to enter 20 like this. We check age and our program runs fully without crashing, right? So this is very nice and this works, but we should still be validating our input instead of just expecting to get an exception, right? So what we're going to do here is we are going to refactor this code a little bit so that we don't need to use this try catch right now. So what I'm going to do is I'll leave that there for now, but I'm going to hit enter a few times at the top and we're going to start writing some code up here. And we're going to say if, and we're going to say not, and then we're going to do an int.try parse. Okay. And what are we trying to parse? Well, we're trying to parse the txt age.text that the user has input. And obviously we want to send out an int age. Okay. So inside of this if statement, we will say message box dot show. And then same thing where we tell them to enter a valid number. In this case, why don't we tell them to enter a valid whole number here and put a semicolon at the end. Remember, we go inside of this if statement if they do not enter a valid int. Okay, and then we'll hit return. And then underneath the if statement is where we can actually do our label text where we say you are age years old. Okay, so why don't we remove our try catch now that we've done this, and let's go ahead and see how this performs, right? So why don't we try typing in ABC and hit check age. You can see that it is validating the user input and letting us know that we need to enter a valid whole number, and then it returns. But if we type in 20 like we were before, you can see that our input is displayed, or our output is displayed to the form. We can also add a range validation, right? So obviously we want the age to be valid, right? So we don't want any negative numbers. And then we probably want to put a cap on the age so someone doesn't enter something like 1,000, right? Because nobody's 1,000 years old. So we'll say if, and then we want to check the range of our age variable. Okay. So if we don't want a negative number, well, we'll say if age is less than 0. And then we also need to check the other side, right? So we need to check if age is greater than something. So why don't we say age is greater than 120? Okay. And then we will open and close curly braces here. And then again, we want to do a message box dot show. And then we are going to let the user know what went wrong, right? So we're going to say, please enter an age between 0 and 120. So we're getting specific with it now if they've entered something outside of this range. Okay, and then we add a return statement right here so that we return and we don't try to do this. So let's go ahead and run this and let's see if our range checking validation is working. Okay, so obviously if we typed in 20 with letters, we need to enter a valid whole number. Okay, why don't I enter 500 as my age? We check, it says, please enter an age between 0 and 120. Okay, let's say that we are 0 years old, and it tells us that we are 0 years old. Awesome. So you can see how we can utilize try catch, right, which we had before. And you can see how we can also utilize if statements to go ahead and try and parse our text. And then if it's invalid, we can show a message box and return. Same thing here. If the user is inputting something that is outside of the expected range, then we can show them a message box saying, what went wrong, what they need to do, and return. And then if they pass these different validation checks here, the output will be displayed to the label result, because that means that our parse didn't fail and we've entered valid input. Okay, so this is just a little bit of a basic example, but hopefully this helps you understand a bit better how validation works within code, because validation is extremely important when it comes to user input, and also how we can use try catch to catch exceptions. In an ideal world, obviously all input is validated to the extent where you don't really need try catch, it's just there as a safety block. But it is good to include both in your programs if possible. So that is the end of this lecture here on chapter 7. Hopefully the difference between validation and exceptions is clear, and hopefully you see why handling exceptions and also validating user input is so important when working with programs. But that is the end of the lecture here, so I will see you guys in the next one.